In this video, I'll explain how to do a number of file operations that are necessary when you are preparing your data to do your data mining tasks. I'll also explain how to do some field manipulations that are common when you need to do data mining tasks. So let's start off by working with an auction database or data set. So I have it here that I've gotten from our example files. If you look at this, it has about 73,000 records in it. And if we view our summary statistics, we can see that we have a number of fields here. Is bad buy is our outcome variable. And if we mouse over this, we can see that about 9,000 of these records were bad buys, and the remaining records, over 60,000, were not bad buys. Also, you'll notice by this that we have a 0 for good buys in our data, and a bad buy is represented by a 1. And so our outcome variable in this case is 0 and 1. 73,000 records is usually bigger than we work with when we are crunching data, even when we're doing things like correlation matrices. So if I put this and create a correlation matrix on it, it takes a while to crunch the data to be able to create the correlations. And it's not a great long time, but it does take some time. And there really is no reason to do 73,000 records necessarily. Very often a representative sample of 10,000 or something like that is sufficient. And you really start seeing some processing pull downs when you're doing some of our data mining algorithms that we're going to learn soon that are very processing intensive. And so it's very common to want to be able to select a random sample of records and get the number down to something that's easier to process and easier for the algorithms to work with. And as long as the data is randomly selected and represents the population, you can work with the sample. And then you can also take other samples and try and make sure things work in your other samples. And so let's say that we're going to do 10,000 records in here. Now we can see some correlation matrices in some correlations in this matrix either by mousing over. And one of the things we're really keen about is what are the correlations that are with is bad buy. So if we click up here, and we can see what these correlations are. And in this example, none of our correlations are particularly strong. You can see that we have a lot of fairly weak correlations. Nothing's really jumping out as being highly color saturated. And this just happens to be a challenging data set. You also notice that it's a little harder to kind of run up and down both a row and a column because it's a little harder on the eye to see because you have to look at both a horizontal and a vertical thing. So from just a convenience standpoint, we may want to rename this is bad buy to maybe start it with a Y or a Z so that we would be able to just have it sort down to the bottom. And then when we look at correlation tables and things like this, which we will do many times throughout the data mining process, everything will just be right down here on this bottom row in terms of that being the outcome variable. So I'm going to close this now, and let's go ahead and rename our field is best buy, and we'll just put a Y in front of that name. And so we'll create a derived data set. We will give it, we'll just say Y auction, and we'll select all of these fields, and we'll unselect is bad buy, and what we will do is we'll create a new computed column, and we'll call it Y is bad buy. And I'm just giving this a name. I could have named anything. I just did this to make a late alphabet value there in the beginning of the name, so we'll sort to the bottom. This is not going to really have a big impact or any real impact on any of the data mining techniques other than just to make it easy for you to see what that value is. The other thing we'll do is we'll create the outcome variable so that we have a yes or a no. And so if we go down and look here, one of the options here is an if function. So we can select this if function, and it will help us be able to create our if statement. So this says if condition. So what we'll do here is bad by, if that equals 1, then this is the do if true. So we'll say yes, and when you use literals, you have to put them in quotes. Otherwise, we'll put in the word no. Now when we do this, we'll be able to see the formula up here. By using this little if template, it helped us fill this out. We're not limited to one if statement here. You could actually do a series of different formulas. We're also not limited if statements. We could just do simple math. We could say something like, age of the car equals today minus the manufacture date, and that would give us the age of the car. So there's lots of different things like that that are useful to do when we're creating this. I'm just showing a simple example here. And then we'll hit create. So now when we do this, it'll make a file called yauction. It'll have all of these variables in it except for is bad by, because we've now created a new one that is called y is bad by, and we'll create that. Now when it does this, there are a couple of things that happen. When you create a new file or a new sort of data set, what you're doing is, if it shows up with a green icon here, it has not been saved down to the directory. So in other words, this is really just in memory, in computer memory, and has not been saved as a file yet. One of the things we can do by right-clicking on this is we can save it as a data set. So I'm going to go ahead and do that. So now you'll see it's got the .csv, so this is actually being saved out to the very same folder on the computer where auction.csv is. If we now go in and look at the summary statistics now, then you'll notice that y is bad by is down here at the bottom, and now we have our no's and our yeses. Of course, it's the same number, just a little easier to see. And so we'll hit close now. And we don't need to keep this around, so we can close this. We'd like to get this down to some reasonable number. There's nothing sacred about 10,000. I could have chosen 8,000 or 12,000 or 15,000, but just for a nice simple round number, I'll choose 10,000. I'd like to be able to kind of overload the sample so that we have more representation in our sample than 8% for the number of bad buys. Data mining algorithms need good data and enough records to actually learn from. And so if you have a data set that has an underrepresented group, for example, is bad buys here is only about 8% of the population, it'd be nice to get it up to 20 or 30 or even 50% so that the data mining algorithms could be able to have plenty of bad buys to learn from, and then have mixed in with there a number of good buys so it can differentiate between the bad buys and the good buys. So to do that, one easy way to do this, there's a number of ways we could do this. One, we could go into the parallel plot and we could use the parallel plot to do it. So I could go in and create a parallel plot, and then I could create a filter that would allow us to get the is bad by. So for example, we could take this filter and we could just circle is bad by down here. Okay, and I guess that's not a bad buy, it's the no. And so we could do this, and you'll notice that this filter is down here, and so by right clicking on this we could make data set from filter, and it'll work just fine. So I'll just say goodbyes. Okay, and so it's created a data set. So I'll close this now. So it's left a note for myself. These are good buys, and here's our 63,000 records. And so now what I'd like to do is I'd like to find out. So now I have my good buys. Let's get our bad buys. And one way we can do that is by taking the difference. So if I take this data set and drag it over this one, I can create a data set from the difference. And so now what we have is we have the ones that are not bad buys, and we have the bad buys here. And so notice here that if I put my cursor over this green thing and not over the name, If I put this over the green thing and right click on it, one of the things I can do is I can view or edit the name and notes. And so I'll put this up here as bad buys. And we'll call this something a little more easy to remember. We'll say good buys.